Hi, here is a walkthrough of the full YOLO assessment project. I will show the setup, the PyTorch and ONNX inference pipelines, how detections are generated and how both models are compared based on intersection over unit. Here is the structure we are using. This is the readme file. Requirements.txt contains Ultralytics, ONNX Runtime, NumPy, OpenCV, etc. Utils.py shared helper utilities, drawing bounding boxes, converting YOLO output formats, reading and writing. Let's start with the initial setup. To set up the project, we create a virtual environment and install the requirements dependencies. Okay, let's start. Let's start with the PyTorch file. This file loads the YOLO V8 PyTorch model using ultralytic and performs object detection. The model predicts bounding boxes, confidence scores, and class probabilities. YOLO automatically applies non-max suppression, confidence filtering. The output is a list of detections like XYZ. Let's execute this file. It consists of tclient1.web. This is the file it taking as an input. The model predicts bounding boxes, confidence score, and class probabilities. YOLO automatically applies non-max suppression, confidence filtering. The output is a list of detections like x1, y1, x2, y2, and scores. This is the created file which detected the objects. This is the reference output because it is generated by the original PyTorch model. Then the export to ONNX.py file. This script simply export the PyTorch YOLO model into an ONNX file. Let's execute it. ONNX is a portable format useful for running inference on different backends, GPU, CPU, edge devices, and it has created the YOLO 11 and ONNX file. Ultralytic export done. Now let's move on to the next file, ONNX.py. It taking the same input file, this one. This file loads the model.onnx file using ONNX runtime and performs inference manually. Let's execute the file. How ONNX inference work? Image is resized to 640 by 640 size, normalized into tensors. Model outputs raw predictions, no automatic processing. We manually perform filtering, confidence thresholding, non-max suppression, converting bounding box format, then save the annotated image separately into runs. Here the predicted file is received. And here is the output file. Predict 8. Detection is completed. It's showing 1 person, 2 cars, 2 giraffe, and the score is this. The PyTorch result was this, and the ONNX detection result is. The values are slightly different in ONNX versus PyTorch because ONNX does not apply the exact post-processing that Ultralytics PyTorch uses internally. Very tiny numerical differences are normal, but overall shapes and positions must match. Now let's execute the last file to compare both the results. This file compares both models numerically to check accuracy. Input PyTorch detections from inference slash pytorch.py onx.py file. It matches box class to class, calculates IO intersection over unit, prints match percentage, flags mismatches or missing detections. This ensures the ONNX model is performing close to the original PyTorch version. Here 948 and 87 both are close. To summarize, we built a full pipeline that runs object detection using YOLO in two formats, PyTorch and ONNX. We generate annotated images, extract structured detection data, and compare both outputs to validate model consistency. Complete assessment workflow showing how both models behave on the same input image. These are the tested images. It's detecting the cat, suitcase, book. Thanks.